Assalamualaikum and hi everyone. Today our group will present an industrial visit report conducted at ATB Oil Terminal Tanjung Bin Johor. The focus of this presentation is on four major electrical equipment observed during the visit, namely the transformer, vacuum circuit breaker, variable speed drive with motor system and emergency diesel generator. We will discuss their specification, function, industrial application, issue identified during the visit, and proposed improvement measure. Before proceeding, I would like to introduce the member involved in this industrial visit and presentation. My name is Nazira binti Azrul Nizam and my group mates Putrino Alia Balkis and Ibrahim Abuza Ibrahim. The industrial visit was conducted to provide exposure to real industrial electrical system and equipment used in petroleum storage terminal operation. The first objective was to understand how electrical power is distributed from the utility supply to industrial equipment. The second objective was to identify the function and application of major electrical equipment used in ATB. The third objective was to observe industrial maintenance practice and operational procedure implemented by the company. Finally, this visit allowed us to relate theoretical knowledge learned in electrical engineering course with an actual industrial application. ATB Oil Terminal is an independent petroleum storage terminal located at Tanjung Bin, Johor. The terminal provides storage, blending and distribution service for various petroleum products including gasoline, diesel, fuel oil, jet fuel, bitumen and biofuel. ATB began operation in 2025 and currently operate with more than 1.4 million cubic meter of storage capacity, including 6 jetties and 59 tanks. Because the terminal operates continuously 24 hours a day, a reliable electrical system is essential to support all loading, unloading and storage activity. Okay, now I will present three major activities in ATB operation. The first is product receiving, where petroleum products are transferred from vessel into storage tank. The second is product delivery, where products are transferred from storage tank back to vessel or customer. The third is intertank transfer or ITT, which involve transferring product between storage tank for blending and inventory management purpose. All of this process depend heavily on electrical driver pumps, making electrical reliability extremely important for terminal operation. Okay, this slide summarizes the four major electrical equipment selected for this presentation. The electrical power first passes through the transformer before entering the medium voltage distribution system. Next, the vacuum circuit breaker provides protection and switching function. Then, the variable speed drive control motor operation according to process requirement. And finally, the emergency diesel generator provide backup power during utility supply failure. Together, this equipment ensures safe, reliable, and efficient operation of the terminal. As we can see, this diagram illustrates the overall power flow within the terminal. It starts with supply from the TNB 33 kV network, and at the end, during the utility supply interruption, the EDG automatically supply power to critical load. Okay, so for the first machine we saw during the industrial visit at ATB is transformer, which is transformer TR9501. The transformer is rated at 6,300 kV ampere and operate at 33 kV on the primary side and 3.45 kV on the secondary side. It used the Onan cooling method, which stands for oil natural, air natural. The main function of the transformer is to step down the incoming utility voltage from the 33 kV to the 3.45 kV. It also provides electrical isolation between the transmission network and the plant electrical system. In addition, it serves as the main power distribution source for downstream electrical equipment. For the application of this transformer in ATB, it supplies power to the medium voltage switchgear, VCB, VSD, and large pumping system used for petroleum transfer operation. Without this transformer, the electrical power received from the TNB cannot be utilized by the process equipment. So overall, this transformer is one of the most critical components in the entire electrical system because it acts as the interface between the TMB supply and the plant operation. We managed to get the SLD for all the transformer, and this is the single line diagram for TR9501. It shows how the transformer is integrated into the ATB electrical system. You can see the 33 kilovolt incoming supply enter the transformer, and then the power is then distributed through the bus duct, ACB and bus bar system. This SLD demonstrates the complete power path from the utility supply to the final motor driver pumping system for this transformer TR9501.
This slide shows the ABB VMAX vacuum circuit breaker observed during the visit. The breaker operates at 12 kilovolts and has a rated current of 630 amperes. It is capable of interrupting fault current up to 25 kiloamperes. The vacuum technology is used because it provides efficient arc extension and high operational reliability. The vacuum circuit breaker provides protecting, switching and isolation function within the medium voltage network. During normal operation, it allows power to flow through the feeder. During fault condition, it rapidly interrupts the fault current and isolates the affected section. The vacuum interrupter extinguishes the electrical arc quickly, reducing contact, wear and maintenance requirement. At ATB, the VCB protect feeders supplying variable speed drive and medium voltage motor used in pumping operation. This ensures that any electrical fault is isolated locally without affecting the entire distribution network. The VCB plays a vital role in maintaining electrical system reliability and personal safety. Next, this slide presents the variable speed drive and motor system observed during the industrial visit. It is important to note that we were able to inspect the ABB ACS 1010 variable speed drive, but we did not have access to the actual motor connected to that specific VSD. Therefore, the motor shown here is a different motor observed within ATB, but it still operates using VSD control and it is one of the motor at ATB. Not all motor in ATB use VSD because VSD are typically installed on pump requiring speed and flow control. The VSD control motor speed by varying output voltage and frequency. It enables soft starting and soft stopping, reduce mechanical stress and improve energy efficiency. The motor converts electrical energy into mechanical rotational energy to drive industrial pump. Because the VSD control motor are commonly used for circulation pump, loading pump and transfer pump. The ability to vary motor speed improve process control and reduce energy consumption. So in conclusion, the VSD motor combination provide both operational flexibility and significant energy saving compared to fixed speed operation. Next, this slide shows the internal operating stage of the ABB ACS 1010 variable speed drive. The process begins at the power input section where medium voltage AC powers enter the drive. The input converter then converts AC power into DC power and the DC links move and stabilize the DC voltage while acting as a temporary energy storage. The output inverter converts the DC power back into AC power with adjustable voltage and frequency. Finally, the output filter and sensor reduce harmonic and continuously monitor system parameter for protection and control purpose. Lastly, this process allows precise control of motor speed while maintaining efficient operation.
So this slide presents an intensity of the generator. The generator is rated at 330 kilowatt with an output power of 264 kilowatt. It operates at 460 volt and 50 Hz. So under the normal condition, the generator remains in standing mode and only operates during critical operation. All scheduled maintains testing. So here is the generation function and application. So the first part is the function. So the emergency diesel generator converts chemical energy stored in diesel fuel into the electrical energy. It provides an independent backup power source during mandatory supply interventions. So the application in ATB. At ATB, the generator supports critical systems such as emergency lighting, fire protection system, communication equipment, and essential operation loads. The generator works together with the automatic transfer switch to ensure the interrupted operation of critical equipment. So this slide represents the issues identified during our visit. So firstly, for the transformer, ground settlement cases movement of the transformer body, creating mechanical stress on the connecting bus bar system. Secondly, for the vacuum circuit breaker. So deterioration of the rubber switch holder results in the slow opening and closing operation. Third, for the motor system, So abnormal operation noise was detected, indicating possible bearing wear, sharp mislighting of mechanical imbalance. So the last thing is for emergency diesel generator. Excessive water accumulation was found inside the diesel fuel tank due to infrequent operation. So here is a suggestion of improvement. So firstly for the transformer, the foundation rectification and periodic alignment inspection are recommended to prevent further settlement and dispatch stress. So for the vacuum circuit breaker, the damaged switch holder should be replaced with more heat-resistant material. The repeatable inspection of the operation mechanism should be included in the preventive maintenance program. So these three improvements will improve reliability and reduce the risk of unexpected failure. Okay, for motor system, condition monitoring technologies such as the vibration analysis, alignment inspection, and bearing monitoring should be implemented. These methods allow early fault detection before serious damage occurs. For generator, periodic water, drainage, and fuel quality inspection should be conducted. Longer generator operation period during routing tests can also help reduce the moisture accumulation inside the fuel tank.